All right, so the next phase, once you've started to get the hang of simplifying identities, now we're going to go into proving identities. In a way, sometimes this can be a little easier. It depends. With simplifying, you kind of just any way, shape, or form, just trying to get it down into a single trig function. So sometimes you have a couple options. But what's nice about proving identities is you know exactly what you're trying to get. Now the bad thing is if you get something else and you think you've simplified it and it's not what the other side is equal to, then you're not done. So here's what these look like. Again, what we're trying to do is I'm trying to take this left-hand side. I'm trying to get it equal to the right-hand side. And I'm saying that because, as obviously you can see, the right-hand side is a little simpler looking. If you're never not sure what simpler looking means, remember simplified means, the simpler version means there's fewer trig functions. The fewer number of trig functions. Here I just have a secant and that's it. Here I have 2 trig functions of sine and secant. So I need to somehow get the left-hand side to equal the right-hand side. So we do that by using our trig identities. So our trig identities, in this case, notice I have, it looks like some reciprocal identities I could possibly use because these are being multiplied together. So remember, this 1 plus secant is not attached because the sine squared is there. Order of operations says I have to deal with this first. So I'm going to rewrite this as 1 plus, and I'm going to write this as 1 over cosine squared theta times sine squared theta over 1. So this becomes 1 plus, notice sine over cosine is a trig identity. So I'm going to write this as tangent squared theta. Now, if you know your Pythagorean identities, you can kind of see that we're basically done. And this is where seeing the other side is kind of helpful. Like, oh yeah, there is a Pythagorean identity. 1 plus tangent squared is secant squared. So I can take this and say secant squared theta is what 1 plus tangent squared theta equals. And that equals my right-hand side. So notice those are now the same. That's when you know you're done. Now obviously you know the answer to these problems. I have to grade the work on these. The work is what matters. So if you can't prove it to me by showing me every single step, what I mean by that, if you skip a step, that's missing points. You've just not proven to me that they're equal. You kind of cheated your way to it. So you have to show every single step or else this will not count. So make sure you are doing that on these, or else again you are not doing what I'm asking you to do, and that's prove that they're equal. So proving means you have to show me how. Alright, so number 5, what we're going to need to do here is get this right hand side. I need to make that right hand side turn into a cosine squared. So in order to do that, it looks like we have some reciprocal and some quotient identities that I can apply. So I'm going to take my right hand side, I'm going to write that as 1 over sine theta times cosine theta over 1. This is divided by, now I'm going to use some quotient identities. Tangent is sine theta over cosine theta plus cosine theta over sine theta. And now what we have is we have a bunch of fractions. I'm going to make it so that I have one fraction over one fraction. That will allow me to keep change flip. So on top it's kind of easy because they're just being multiplied. This is just cosine theta over sine theta. Now on bottom we got to do a little bit of work. Nothing too crazy, but we have some stuff to do here. We got to get a common denominator of cosine sine. So I'm going to multiply here cosine on both sides, on top and bottom I mean. On the left hand side I got to multiply by sine on the top and bottom. So that gets multiplied, and you'll notice this will become sine squared plus cosine squared divided by sine theta cosine theta. This becomes 1. You still need to write it, but that's just going to be 1. So when I do keep change flip, I don't have to copy that down again. So this will be cosine theta over sine theta times sine theta cos theta divided by 1. That's obviously very useful because now the signs cancel. You get cosine squared theta which is your left-hand side. So again, very useful to use those. And this one I ended up using multiple identities. And again, you just look and see, well, what identities can you use? And then just start using them and doing algebra. If you do that, you should be able to get to your answer. To finish up here, we have 2 more to do, just to give you some practice here. So on number 7, it may be hard to see which side needs to be simplified, but remember, look at how many unique trig functions there are on each side. The right-hand side here only has 1. The left-hand side has 2. So I'm going to start with the left-hand side. So the left-hand side, I'm going to look, I need to rewrite it in terms of sine. So I'm going to use this Pythagorean identity where I can take cosine squared and write it as 1 minus sine squared theta. If you take that Pythagorean identity and apply it, notice this one doesn't take long at all. Some of them don't take very long. It just depends on the problem, you know. But this one is already solved. That equals your right-hand side. So notice some of them are short, some of them are long. You just have to look at your identities and apply them and hope it doesn't take too long, you know. So that's number 7, fairly short. And then we're going to finish up here on number 12. So number 12, notice I got 1, 2, 3, 4 trig functions on the left. So definitely I'm going to start with that left-hand side. Now again, on this one, very similar to the one we just did a couple problems ago, I have some reciprocal identities. Actually, just 2 quotient identities really for cosine and cotangent and tangent. So I'm going to apply them and probably do a little keep change flip and see what we get. So here we go. This is going to be cosine, cotangent is cosine theta over sine theta, minus sine theta over cosine theta, and this is all over sine cosine. Can't do anything with sine cosine other than put a 1 underneath it. So I'll do that. Just to remind you, I'm going to keep change flip here in a minute. Before I keep change flip, I have to get common denominators. So I'm going to multiply here by sine theta on top and bottom. Other side, multiply by cosine theta, top and bottom. So this becomes cosine squared theta minus sine squared theta divided by sine cosine. And now I'm going to keep change flip. So I'm multiplying by that denominator 1 over sine theta cos theta. Now notice it's not canceling. That's okay. You got to look at what we're trying to get on the other side. We're not there yet. So this will be cosine squared theta minus sine squared theta. This is now over sine theta squared. So sine squared theta cos squared theta, because what I'm doing is I'm multiplying my denominators together. So we're just squaring those terms. Now this is where it gets really cool. So what I have is a common denominator. What I want to do is I want to separate this common denominator. So I'm going to write this as cosine squared theta over sine squared theta cos squared theta minus sine squared theta over that same common denominator. I'm just separating it. So this is going to be over sine squared theta again, cos squared theta. This is a very common theme in simplifying trig identities, so it's not like this random made-up thing that I just noticed right off the fly. Separating fractions is a simplification strategy here that I'm using, so I'm bringing this up on purpose. I wanted you to see this one because it is a skill that gets used quite often. Because now I can simplify, I can cancel out my cosine squareds. Here I cancel out my sine squareds. So you now have 1 over sine, which is cosecant squared theta, minus 1 over cosine from my other one. Well, 1 over cosine is secant. So this will be secant squared theta. Now if you look, my right-hand side, that's my right-hand side. So I am done. So that is proving trig identities. Again, make sure when you prove them, you must show every step. So don't skip steps. If you ever have to ask yourself, should I show this step? Don't ask me if you should. Show it. Because if you're going to ask me that, I'm going to say yes. So make sure you're showing every single step that you can, and it takes practice. So obviously we have some practice to do at this point.